All right, let's jump right in. Today, we are going to decode the modern AI stack. You know all that jargon you hear? We're going to cut right through it. The goal is simple, to turn a super complex glossary into a clear story. We'll give you the 25 key terms you absolutely need to know so you can speak the language of AI with confidence. Let's get started.
So we're framing this whole thing as a journey, like we're building an AI right from the ground up. We'll start with the blueprint, then move into how it learns, figure out the difference between giving it new skills versus new knowledge, make it efficient, and finally get it out into the real world responsibly. This is our roadmap.
First up, the AI blueprint. I mean, before an AI can learn anything, it needs a structure, right? So this section is all about that fundamental architecture, the core components we put together to create the brain of our model.
At the very heart of pretty much every modern AI is the neural network. It's basically a model made of mathematical layers, and it's designed to recognize patterns by adjusting these internal connections. Just think of it as the basic scaffolding for the AI's brain. It's the structure we build everything else on.
So how does this brain actually, read? It all happens through what we call the data pipeline. First, tokenization breaks down text into smaller, manageable pieces. Then, embeddings convert those pieces into numbers or vectors, where similar ideas are kind of grouped together mathematically. And finally, the transformer architecture processes all the complex relationships between those vectors. This is literally how we get from human language to machine understanding.
And what's the real superpower of that transformer? It's something called the attention mechanism. This is how a model genuinely understands context. It lets the model figure out which words in a sentence are the most important, allowing it to pick up on nuance and generate responses that actually make sense. Okay, so we've got our blueprint. Now, let's actually bring it to life. Welcome to Section 2, the learning process. You can think of this as the education phase, where our model goes from a total blank slate to a tool that can start to reason and think. So, that huge initial training, it happens through something called self-supervised learning. The model is just fed a mind-boggling amount of text from the internet, and it basically teaches itself by playing a giant game of fill-in-the-blank. It's constantly trying to predict missing words. This is how it learns the fundamental patterns of language and knowledge all on its own.
After that big initial training, we have to refine the model, and there are a few key ways we do that. First, there's RLHF, which stands for Reinforcement Learning from Human Feedback. That's where we get humans to rate the AI's answers to align it with our values. We also use prompt engineering to guide it in real time with really specific instructions. And for image generation, there's a special process called diffusion models, where the AI learns to create a clear picture by starting with digital noise and cleaning it up.
So our model is trained. It's smart, but the world changes fast. This brings us to a really crucial question. How do we upgrade it with new info and new abilities without having to do that whole expensive training process all over again?
Let's just put the question right out there, because this is one of the biggest challenges in AI today. After you've spent all that time and money on the initial training, how do you actually teach an old model new tricks or, new facts? Well, one way is called fine-tuning. This is where you take your general-purpose model and you train it just a little bit more on a smaller, really specific data set. This teaches it a new skill. The best analogy, it's like a general practice doctor who goes to a master class to become a heart surgeon. The core knowledge is already there. We're just adding a new specialized capability.
The other main method is RAG, which stands for Retrieval Augmented Generation. Now with this, you connect the model to an outside source of information, like a database. This gives the model new knowledge. It's like giving a student an open book for a test. They haven't memorized the entire book, but they know exactly how to look up the right answer when they need it. Okay, let's be absolutely crystal clear on this, because this is the one thing that trips almost everyone up. Fine-tuning teaches a new skill. It actually changes the model's behavior. You use it when you want a different style or a whole new capability. RAG, on the other hand, provides new knowledge. It gives the model access to outside facts. So you need up-to-date info? Use RAG. You need the AI to act differently? That's fine-tuning. Skill versus knowledge. That's the key.
So, we've got a smart, capable model. Awesome. But there's a huge problem. These things are massive, and they're super expensive to run. That brings us to our next section, the efficiency tune-up. This is where we make powerful AI practical for the real world.
The goal here is actually pretty simple, but it's incredibly powerful. We need to take a giant base model, which can be like 100 gigabytes or even more, and shrink it way, way down, hopefully without losing too much of its performance. This is what makes AI faster, cheaper, and lets it run on more devices, maybe even your phone.
So how do we do that? Well, there are three main techniques. First, there's quantization, which shrinks the model by basically using simpler, less precise numbers. Then there's distillation, where a little student model is trained to copy the behavior of a much larger teacher model. And finally, you have methods like LoRA, which let you fine-tune a model super efficiently by only training a few small extra layers instead of the whole thing.
There's also this really clever architecture called a mixture of experts, or MOE. Here's the secret. A giant model is actually a team of smaller specialized models. When a question comes in, it only gets sent to the expert that's best suited to answer it. It's a divide and conquer strategy that lets you build these enormous models that are still really efficient to run.
We've built our model, we've trained it, we've optimized it. Now for the last and, honestly, the most critical stage of all, deploying AI responsibly. This is how we take our AI out of the lab and put it into the real world, safely, reliably, and ethically.
See, in the real world, you run into two massive problems. First, hallucinations, which is just a fancy word for when the model makes stuff up. And second, model drift, where its performance gets worse over time as the world changes. We deal with these problems by setting up guardrails, which are just rules to keep the output safe, and by constantly monitoring and retraining the model to keep it up to date.
And for any serious business use, reliability is everything. That's where something called a deterministic wrapper comes in. AI models are by their nature a little unpredictable. So what we do is we wrap them inside some predictable logic, like strict formatting rules. This makes sure that even if the AI is being creative on the inside, what comes out the other end is structured and reliable every single time.
The full Enterprise Toolkit has a few other key parts. Models get connected to apps through secure APIs, which are like controlled gateways. You can also build multi-agent systems, where a whole team of different AIs work together on a problem. And, super importantly, we use something called explainable AI, or XAI. These are tools that help us understand why a model made a particular decision, which is absolutely critical for building trust.
And finally, all of this, the whole shebang, is wrapped in a framework of data governance and AI risk management. This is the non-negotiable layer. It covers everything from data security and who can access what, to making sure our AI is used responsibly, ethically, and legally.
And there you have it. We've just walked through and assembled the entire modern AI stack. We started with the basic blueprint of a neural network, went through training and optimization, and brought it all the way to a responsible, real-world deployment.
So now you have the vocabulary, you have the mental model to really understand how these incredible systems actually work. The final question, then, isn't really about the how anymore, it's about the what. The toolkit is here, it's ready. The real question is, what are we going to build with it?